With this information, I would like now go to each application and give you some sort of advice of how to define some of the properties in LedaFlow and GEM. Here in LedaFlow, you go to the inflow zone device. In general section, the inflow type and the inflow performance relationship should be IPR table mass. And if you go to the edit section here, you need to define your IPR table. At the start of the simulation, these numbers would be arbitrarily selected by yourself, and they would be acting as a kind of placeholder for the actual IPR table will be generated by GEM at each handshaking time during the simulation. We suggest to use the BHP type column for the IPR table in here, and the number of the rows in here that you select needs to be consistent with the number of the data points that you define in GEM model. At the moment, you can see we have used 20, and I will show you later on in GEM dataset where we define that number in our GEM model. Click OK. Another input which is very important is the geometry or the length net pay of the inflow zone device in LedaFlow. That length needs to be equal to the interval of the perforated zone in GEM model, which is a distance from your top perforated grid block to the bottom perforated grid block in GEM dataset. In the positions tab in here, you need to make sure that the place of the zone inflow zone device is at the bottom of the perforated grid block in GEM. So that would be the start of your inflow zone device in LedaFlow. Click OK. Now we go to the GEM model, which I have opened it in here in our cedit. If you go to the well and recurrent data section, you can see I have used the operate max BHP keyword in here, which that allows us to effectively scatter our all data points over the range of the BHP in the IPR table. The next keyword that I have used is the BHP depth keyword, as we discussed earlier. That makes a kind of position for the report of the BHP in GEM equivalent to the center position of the inflow zone device in the LedaFlow. The next keyword is the IPR tab, and that's the keyword that you can use to define the number of the data points for the IPR table. The default number is 10 if that keyword would be absent in the data set. But in certain cases, when there is a nonlinear relationship between rate and BHP, we recommend to use the higher number in here. And as you can see, we have used 20, which is equivalent to the 20 rows in the IPR table defined in our LedaFlow model. So with that, we reach to the end of the video here. I would like you have found this information and guideline helpful. And thank you very much for watching this session.